So welcome. This is the first in a series of 2 webinars on cloud storage migration. I'm Vas Vasiliadis with the Globus customer team. And today I'm going to talk about how Globus is being used and can be used, not just to migrate data to the cloud, but also to move data between different cloud service providers, to distribute data to different cloud service providers, and also to move data from the cloud to on-premise. All those types of flows are things that people are doing fairly routinely nowadays. I'm going to talk about what some of that looks like, do a quick demonstration, and then I'm going to walk through how you can actually set that up in your environment using Globus, and also some very important considerations and things you should be thinking about if you're going to go down this path. So the first thing I want to discuss is thinking about cloud storage as what I call data appropriate. So in most institutions that we work with, they have literally one of everything. And the users, the researchers, whomever, pretty much decide, where they're going to put their data. In some cases, they'll dump a petabyte on Google Drive, or they'll put something, on OneDrive or what have you. And then there are perhaps some challenges to getting it off there or working with it in that environment. And so, the one thing we encourage people to do is get the users to think about, access frequency or data temperature, right? How often is the data going to be used? What are the access modalities? Is it going to be mostly data you're pointing and clicking on a browser? Is it data that's going to be fed into scripts for, HPC or HTC type jobs? Or is it going to be something that's sort of programmatically accessible as part of longer, larger workflows, things like that? All of that really should guide where the data actually end up. So, for instance, if you had something like Box perhaps, or Google Drive, when they have unlimited storage for a fixed price, that certainly encouraged users to put a lot of data onto those storage systems. And now there's a need to migrate off of those. And so the good news is that you can actually use this as an opportunity to get users to move their research data, their big data, the data that they're working on that's more active, put it in other storage systems that are better suited to using them, to using their data in research flows, and then leave their smaller data, their project admin files, and so on Google Drive or Box or OneDrive or what have you. But in any of those scenarios, it's still very, very useful. And one of the benefits that Globus brings to the table is to allow you to access these storage systems through a single pane of glass, to use sort of the admin term. It's basically a unified interface that allows you to go through and touch any of these different storage systems, and they all look the same. So I'm showing here a whole bunch of different ones, and I'll actually show you this live in just a second. But the idea is, if you have a POSIX file system, you can browse that, but then you can just as easily browse any of the many different object stores that are supported through what we call Globus connectors. And many of these have S3 compatible interfaces. So for some of them, a single connector can actually allow you access to many different types of storage as well. Another really big benefit of using a service like Globus to do this is not having to worry about limits. So all of the storage cloud storage providers have limits, for instance, on the API rates, so how many requests or calls you can make to the API every so often. Google Drive, I think, has a default of 5,000 or 10,000 calls every 100 seconds, and Box has some other number. And so this is something that, if you were to move, let's say, a little bit of data, like a terabyte, which for many of our users is not a lot of data, but even that amount of data can actually trigger these types of limits and actually have your performance throttled, actually have your in some cases have the transfer basically sit there in a state until the clock is reset by the cloud provider. And it can be frustrating for the user, because if you're doing it through some other tools, they'll just sort of give up because they're not getting a response. The nice thing about and the other thing, by the way, there's also limits on data volume. So for instance, Google Drive, I think, has a data limit of, I think it was 750 gigabytes a day, or terabyte, or thereabouts. It's a lot of data, but if you're actually going to migrate tens of terabytes, or in some cases petabytes, that we know many institutions have on systems like Google Drive, that's really not a tenable situation. But there's no way we can circumvent this. So the vendors in general don't allow sort of special cases or ways to get around these limits, obviously, so they can ensure quality of service. So that's understandable. But you can use Globus and our sort of fire and forget approach, and send these transfers off, even if they start sort of ringing bells and triggering limits. The transfer will eventually complete, and Globus will ensure that it gets done in the most expedient manner possible, and the data integrity is maintained. And as a user or as an administrator, you don't have to sit there and worry about it. There are some limits that we just can't do anything about. So file size limits, for instance. Google Drive, I think, has a 5 terabyte file size limit, so that doesn't tend to be a problem. But some of the others, like OneDrive and Box, have a couple hundred gigabytes or thereabouts. So if you do have some really large files, if you're doing genomics analysis and you have raw whole genome sequences, things like that are many hundreds of gigabytes in some cases, that can be an issue. But that's not something that we can really address. But we do have the tools to let you put those kinds of files in an appropriate storage system that can handle that size. So let's take a quick look. What would you see if you're accessing any of these cloud storage systems through Globus? I'm going to log in here using my Globus ID. I could have logged in with any one of over 1,000 identity providers that we support in Globus. And let's take a quick look first. I'll go down to my Google Drive, since I've been picking on them quite a bit. So you'll see the first time that a user tries to access this, once it's been set up by the administrator, they have to authenticate, say who they are, make sure that they have an account that's able to use that specific Google Drive instance. So I am with the University of Chicago, so it's prompting me to use my UChicago credentials to log in. So I'll go through what might be a familiar flow, where I'm logging into Google, and I'm consenting, I'm granting access to allow this connector, to allow Google to access, Globus to access Google Drive on my behalf. And then I get dropped into my Google Drive. And you can actually see it here. This is my actual Google Drive in my browser. So I'm looking at the exact same thing through Globus. If I wanted to, say, go from there to my, let's say my box collection. Let's see if I can find that one. There's box. So let's say I had a box drive as well, or OneDrive, all of the above. They all look the same. So I can just literally point and click at this point and just say, move that data from there, or move that over, and so on. So that it's as simple as that. From the perspective of an end user, and I'll talk about some strategies for how you actually go about moving things at scale. Obviously, if it's just a few gigabytes, terabytes, you can just have the user do that, but there are other considerations that we should be thinking about as well. So what does it take to do this? Most of these, in fact, all of the connectors, with the exception of just a regular POSIX file system, require a Globus subscription, but we're more than happy to set up trial subscriptions. They're good for up to 90 days. So you have plenty of time to set things up, do transfers. And if you're looking at moving between two systems, we can set it up such that the subscriptions, you have access to an additional subscription for a short period of time, so you can do your migration, and then you continue using the new system that you've migrated to ongoing. So once you have the subscription, you can set up a Globus Connect server. That's the software that creates the Globus endpoint, and then on top of that, you set up a what we call a storage gateway, and this is really important because this is where you have to do things a little bit differently for each storage system depending on what the cloud provider requires. I'll talk about that in just a bit here. Once you have that, then you can create the mapped or the guest collections, as we call them. So what I was looking at, what I was showing you on the screen just now, those were collections. That's what the end user sees. So steps 1 through 3 are administrative, well, step 1 through 4, I should say. And then at that point, the user has access, and they can point and click and transfer and do their thing. So as I said, the deployment will vary by cloud provider, but there are some things that are fairly common across all of these different cloud connectors. One of them is that you typically have to register some type of application with the cloud provider. So I'm showing here an example from Google Cloud Platform where I registered my Globus connector, my endpoint, my storage gateway rather. So through that registration, typically you get some set of credentials that you can then use in the next step, which is to set up the storage gateway. So I register, get the credentials, use those to set up the storage gateway. And in that storage gateway, very importantly, is where you would specify access policies. So for example, if you wanted to limit access only to some buckets on Google Cloud Storage or on S3, that's where you would specify that. If you wanted to limit access only to the shared drives on Google Drive or the team drives, that kind of thing is something that you would specify in the access policies associated with that storage gateway. And that's where you also decide what type of credentials the user must present to access the data. So you saw in my case, when I was trying to access that Google Drive instance, it prompted me to log in with my UChicago identity. I couldn't offer up any other kind of login, even though I was already logged in as Vasa, with my Globus ID. That wasn't sufficient. I had to explicitly authenticate with a UChicago identity. So it's a number of layers of security here that work together. And the other thing that you may have to do in some cases is figure out how to map the accounts on that cloud storage system to Globus accounts. In many cases, if your institution uses the same username in your identity provider as you do to access the cloud storage, that actually can be pretty straightforward, but some cases you might have to do some mapping, and we have very versatile and flexible tools to do that. But another way to get around that is through the use of guest collection. So I didn't show you that, but one thing you can do with Globus is allow sharing of data by someone who has access, who has local account access, if you will, or access to that storage system. They can share out to other Globus users just using their Globus identity. So you don't have to create accounts for them specifically on that storage system. So a good example of that would be if you had a couple of buckets where people have project space, let's say, in the cloud. What you could do is set up a guest collection on each of those in each of those project spaces, if you will, in those prefixes, right, or directories in the cloud. And then you wouldn't have to worry about mapping user accounts or anything like that. The user could simply log in to Globus, go to that guest collection, which is their own, and access their data. Some other considerations that I think are important to bear in mind if you are moving between different storage systems. The one is that the virtual file systems that that object stores present can vary in the way, for instance, that they treat metadata. One of the things that you may notice is if you're moving files from, let's say, a local high performance storage up to the cloud. When you put them in the cloud, they file modification times and things like that are not preserved, because there's no notion of that type of metadata in some of the storage systems. So just something to be aware of. And Globus, again, Globus just does that for you. You don't have to do anything special, but it's something that you should know, that you will see some changes depending on what the source and the destination are. The other thing to consider is we've seen institutions doing things either in bulk, so having the entire or a good chunk of the storage from one system move to another. In some cases, we've seen them sort of hand that off to the users and do it user by user. A lot of this has to do with the size of the transfer request. So we would caution against, firing off multi-petabyte transfers, rather chunk them up into, perhaps, a few hundred terabytes a piece. It just makes them more manageable, also allows you to ensure that you don't swamp the network, because certainly one thing Globus can do through its grid FTP protocol is really put a lot of data out on the wire. And the other thing is, and this is mostly policy, again, some institutions say, well, the migration has to be coordinated and run by the IT folks or the admins. In other ones, they're saying, okay, we're giving our users the tools like Globus to do this, and then we're telling them, how to do it, and then it's really up to them to get things migrated. And again, this is needs to be coordinated, perhaps in the form of user cohorts, so that you can just do it in a more orderly fashion. But whichever approach you take, one of the things that we strongly recommend you do is make sure you have the infrastructure in place to get the throughput that you typically need to move these petascale or larger data sets. You may be familiar with the Science DMZ. It's a design pattern developed by the folks at ESNet, who we work with very, very closely. There's more information at that link, and they're always very available as well through their Epoch Center for engagement to help folks optimize and set up the data paths and the network such that you can take full advantage of these types of tools. We also have something we've been doing jointly with them called the Data Mobility Exhibition, the DME. So there are data sets there that you can use when you're setting up your endpoints to test. And then also, because this is a cloud focused solution, it's really worthwhile if you have Internet 2 access. You can see if you can take advantage of any peering arrangements that Internet 2 has with many of the cloud providers. That way you get really high bandwidth paths directly to the cloud storage. And the Net Plus team, for instance, at Internet 2 is a great resource. So, I think you should definitely reach out to them if you're going to go down this path. One thing to also consider is that, yes, you may have great network pipes, but they're not going to fill themselves. So you need to also think hard about what your data transfer nodes look like in terms of capability. So certainly fast CPUs and lots of cores, because if you're moving lots of files, you have to checksum lots of files, and that takes processing power. But also having them dedicated to the task, not having your DTN double as God forbid, a mail server or something like that. For example, I'll give you some performance numbers on the next slide, but just as an indicator, the AWS endpoint that I used is this order type instance. And the one important thing is that I've actually used instances that give me roughly the amount of throughput, at least guaranteed network IO, that I have on other parts of the network. So I'm looking for at least 10 gigabits per second So this is sort of a good match. And this is where I talk about, so I've got this point here about matched network throughput up above. That's really what I mean, is there's no point provisioning this wonderful network and then using an instance that taps out at a gig or 5 gigs or something like that. And also having a cluster of smaller data transfer nodes tends to be better for bulk migration, because if you're going to have lots of users sending lots of transfers, then Globus can distribute those across multiple nodes. There are also some things that are perhaps a little more esoteric, like you may run into issues between API limits and concurrency and parallelism. So concurrency and parallelism are two things that Globus allows you to set. That's how we get this wonderful high throughput between the two endpoints. There's a tendency to say, oh, you know what, let's just set these values to their highest. In some cases, you can go up to 64 concurrent transfers paths. And the reality is that a lot of the storage systems, because they have API rate limits, if you hit them with so many things in parallel, you're going to hit those limits sooner. And then, a lot of the time the transfer is going to be backing off. So you're actually going to hurt yourself by doing that. So it does require a little bit of planning and research to see what the right sorts of things are. With relatively little sort of tuning and tweaking, using those instances that I talked about, that I mentioned earlier, these are the sorts of numbers that I was able to get. And again, this is without having any fancy network in place. I was just going directly with whatever publicly routable path existed between these endpoints. And once you've set this up, by all means, please do run some experiments before just launching a bunch of big transfers. And also prepare your data. So one of the last thing I'll leave you with is to really try and avoid this lots of small files problem that we see over and over. Lots of small files are just always a problem. They are a big headache, even though they're small. And the issue here is that when you do have 10 million 1 meg files, which we've seen over and over in many large projects, you start running into issues around concurrency, because you can only push so many files through at a time. And an even bigger issue when you're talking to object stores is they have a disproportionate amount of metadata that they attach to every single object. So if you have really small files, actually the metadata that you're writing is actually going to kill you, because that's going to take a lot more space, a lot more time. So I sort of liken it to, if you have kids and they have a bunch of Legos and they've got 100,000 little Lego pieces scattered all over the floor in the basement, and you want to move them upstairs, does it really make sense to go and pick one up each, one at a time, and go up the stairs 100,000 times? Or maybe think about how you can sort of package those, tar them, archive them, whatever, and then make fewer trips. So that's one big thing that I do want to stress, because we do find that a lot of people complain about cloud performance, and it really comes down to the nature of the data and how they've prepared to do that before they launch these massive migrations. So I'll stop there and then open it up to questions. So I ran a little long, but hopefully we'll have some time for questions here. Susan, I don't know if you want to stop. You can stop the recording.